Hello guys, welcome back to my channel, Maison African Motives. In this platform, we shall be focusing on our question paper, which is actually for A-level mathematics, which was written in November 2021. So we have got the first part that we shall just work on and see how we're supposed to attempt these particular questions. So we shall just work with the first part of the question paper. So not wasting much of your time, we have got the first question here that we are given to solve the equation. I'm just going to rewrite this, but we are given that this equation we are supposed not just to solve, but to give your answer in exact form, so that what you're given there to give your answer in exact form. All right, so let's just take down our question down here and see what we are given. So we are given to solve the equation that is 2e. This is 2e to the exponent of 2x, whatever that we have there, minus 7 e to the exponent of x plus 6, which is equal to 0, like that. All right, so this is the equation that you are given actually. In this case, let me just try and reduce a little bit here. All right, so how can we actually solve this particular type of equation? You're given to give your answer in exact form, which is fine, but how are we going to have this in exact form? Okay, so I want us to cross-check here. We've got e to the exponent of 2x, e to the exponent of x. So we can actually introduce this to say, let's just write this as 2 here, e to the exponent of x, which we can write this as exponent of 2, just like this e to the exponent of what? Of x here. So we just want to write in this format. So it's going to be like this, minus 7e to the exponent of x plus 6, which is equal to 0. Why are we actually having this? So that we can introduce this into our equation. Let's just say let y be equal to e to the exponent of x. All right, so that means we are going to end up with a quadratic equation, because the whole of this part here that we are saying is our e to the exponent of x is going to be represented with y wherever there is a e to the exponent of x, like this part here, and also this part there. We are going to replace with what? With y. So in place of this, we are going to substitute with y. So that means our equation is going to just look something like this too. In place of this, e to the exponent of x is going to be y squared minus 7y plus 6, which is equal to 0, like that. So that's what we had, guys. So from this part, let's see what we're going to have, because now we are just left with a normal equation, just like what we are used to in our normal equations using quadratic formula or factorization. I can just use factorization because here I can see that if I multiply these two terms here, I'm going to be left with 12y squared, and I have to find factors of 12y squared that I'm going to use, which is in this case, it's minus 4y and minus 3y. So we can substitute these two in place of what? In place of minus 7y. So that's going to be something like 2y squared minus 4y minus 3y plus 6, which is equal to 0. So you're simply substituting into the middle term in place of your 7y, just like that. Okay, so I think this part we are actually used to this, and how to actually work out this, we are actually used to this part. Okay, but at the end from this part, what are you going to have? Just group your terms into two. That means here we can actually factor out the term that is common, which is in this case is going to be 2y here into 2 divided by 2, we're going to be 1, and y there is going to give us y minus 4y and 2, that would be minus 2. Okay, minus 3, which is common between the last two terms, and you're going to be left out with y minus 2, and everything is equal to 0, just like that. So now taking this part, I want us to see something here. If we are to take this part, as you can see, the brackets are the same. So just take one of the brackets from these two same brackets, which are the same, which is y minus 2, factor it out, you'll be left with 2y minus 3, which is equivalent to 0. So from this part, we are simply saying either one of these brackets must be equal to 0. So your y is going to be a 2, or from this, if you are to see that we have got 2y, which is going to be equal to 3, then you divide by 2 both sides. So which means y is going to be 3/2, which is actually a positive value. All right. But this is not what you're asked. With the question is actually asking us to calculate this value of x, not y. So we need x. So we're going to back here where we said let y be equal to what? To 2 to the exponent of x. So this is where we are going to a to the exponent of x, sorry. So this is where we are going to b. Let's just put this here, guys, so that it can help us. So we said let this be equal to x. So that means we can actually play around this. All right. In place of y, what are you going to do? We are going to substitute with 2. The first part of y is 2 here. So that means 2 is equivalent to e to the exponent of x. Or in place of y, we're going to have 3/2. So it means 3/2 is equivalent to e to the exponent of x. All right, just like that. So how can we have the value of e here? So you know that whenever you're given e, we can introduce ln on both sides. So this is going to be ln of 2, which is equivalent to ln e to the exponent of x. Or in this case, we're going to have ln 3/2, which is equivalent to ln e to the exponent of x. Knowing that we can actually drop these exponents here. We've got an exponent of x here, so it's going to be ln 2, which is equivalent to x ln e, and this will be something like ln 3/2, which is equivalent to x ln e. All right. Which is very, very important because we know that in our mathematics that whenever we are dealing or we are working with this ln e is actually equivalent to a 1. So if we know this and this can be applied, that means here we can actually substitute in place of this e that we have got here, we can actually substitute with 1. Also here, we can actually substitute again with a 1. All right. So making this or substituting the value of 1, that means here we shall just be left with x. So our answer is going to be ln 2. Or here we just be left with x, and our answer is going to be ln 3/2. So that would be the answer there, of which you can just write this as ln 3 minus ln 2. Remember from your laws of logarithms, ln is just a logarithm, guys, just like a normal log. That's your ln. So these were the stages actually that you needed in this case to end up with the values of x. So in exact form, that is in this format. Okay, you don't write as decimals, you write like this. Okay, so that was our number 1, guys. As we saw, we can just have this aside. Let's move on to the other question. Prove the identity. Okay, we are given the identity to prove sine of 2 theta over 1 plus. I'm just going to write it down so that it can at least make sense for us here. All right, so actually here, I think we are done here, guys. All right, so let's just put it aside here. All right, so this is question 2. Number 2, we are given something like sine of 2 theta. Sine of 2 theta, everything over 1 plus cos 2 theta. That's 1 plus cos 2 theta in this case, which is equivalent to tan theta. All right. How can we actually prove this identity? To prove is to make sure that the left-hand side must be equal to the right-hand side. Okay, the left-hand side must be equal to that, to the right-hand side in this case. So that's what you have to prove here. The left-hand side must be equal to the right-hand side. All right. So you have to choose, in this case, the side that you can work with. In this case, I'm just going to choose the more complicated side, which is in this case is my left-hand side. All right, so I'm just going to take this part on the left-hand side. I don't know if I'm going to indicate this, and I know it can't actually work like this. I'm just going to take like something of this nature. I just want us to have this again. All right, so here we are going to take the left-hand side. I'm going to choose the left-hand side. All right. From my left-hand side, what do I have? I have to ask myself, what am I having here? So in this case, I want us to see something. We can actually work out with the denominator here because it's a little bit difficult. Yes, we can apply our identities of sine and cos, but the easiest way that we could have done was to multiply by the negative, like by the denominator, but just introduce a negative here. So it's going to be 1 minus cos 2 theta. If we introduce a negative, and this will be minus 1 times cos 2 theta. So you get used to this type of an identity. Normally, that's the best way that you can actually have this identity in this format. All right, and what you're going to do in this case, we can actually multiply. As we can see, everything now is left for us to multiply the top part and the bottom part. So it's going to be sine theta multiplying this. So we can just write it as sine 2 theta multiplying 1 minus cos 2 theta in this case. So this is cos 2 theta like this. Everything over, we're going to multiply these two. But by multiplying these two, I want us to see what is happening. Okay, let me just write the bracket. Maybe it's going to make sense after writing it down. So this is 1 minus cos 2 theta here. All right, the major important part that I wanted us to achieve was this one. A plus B into A minus B, like this. From your O-level mathematics, you know this is difference of two squares from what? From A squared minus B squared. Okay. So applying our difference of two squares here, it means we're going to change this. Okay, but the first part just multiply as it is. There's nothing that's going to change here. Sine 2 theta multiplies everything there. So it's going to be sine 2 theta minus sine and cos is going to multiply each other here. And it's going to be sine 2 theta cos theta. Okay, so let's just write this as sine 2 theta cos 2 theta. All right. Then everything now over this part where we said we're going to have this as difference of two squares. So what are you going to have at the end if you have to apply the difference of two squares concept? A squared minus B squared, it means we're just going to square this one, and it will be 1 squared minus we square the cos 2 theta here. So it's going to be cos squared 2 theta. All right. Seems like we are somewhere there, but it seems like here I totally rushed in to expand this bracket. So, okay, let's just not expand this bracket. Let's get back here so that at least it can help us. So I'm just going to get back to this original state that I had before because, okay, or you see what's going to happen. Let's move on. We are at this stage now. I want us to see what's going to happen here. Let's take this down again. Let's check. Just okay, guys, this is now too much. I wanted to just have it straight down here. Okay, anyways, I'm gonna put it this way. So I want us to see something that is happening here between these two that we are having here. Let's just put it another way, this way. All right. We're gonna have in the denominator, we are actually focusing with the denominator here. Okay, the denominator. All right, that's our denominator there. So we're just focusing with this part of 1 minus cos squared 2 theta. Remember, guys, this relationship on your identities, actually, you've been working with it and you know this, that cos and sine, cos squared theta, sine squared theta must give us a 1. So in this case, let's cross check what happened here. This is 2 theta, so which means we can just put this as cos 2 theta, sine 2 theta, so that it can now make sense. So we're gonna have this as cos 2 here, sine 2 here. All right. So what actually happened for us to have this part here of 1 minus cos squared theta? What actually happened? That is the question that you are asking ourselves. As you can see, it was actually a matter of transposing this to the right hand side so that we remained with what? With sine squared theta, which is equivalent to 1 minus cos squared theta, but now it's having 2 and 2 here, so it will be sine squared 2 theta, cos squared 2 theta. So so that it can actually match with our question here, that one, the one that you're having. So let us take this down now here. So this is what you're gonna replace here. In place of 1 minus cos squared, we're gonna substitute with this part of sine squared 2 theta. All right. So that means this whole part is going to be sine 2 theta minus sine 2 theta into cos 2 theta, everything over sine squared 2 theta. Okay, so like the part that I was explaining previously, you see here that instead, because we have got sine now, this part of sine, and it's the same thing that we had here. So these two have a relationship. So that is why I'm saying we have to factor out this sine 2 theta again, so that at least it can help us to work out our question. So let's just factor out sine 2 theta. Actually, we're not supposed to expand, but it's fine if you did this. It's going to be 1 minus cos 2 theta. Everything here is going to be over sine squared 2 theta there. All right. This part now we can actually just expand, divide these two denominators. Okay, so we have got something of this nature here. We have got sine 2 theta, 2 theta here, but here there is a square. So the moment we simplify this, we're gonna cancel this sign and this, so which means here you'll be left with one of these sine 2 thetas. So it's gonna be one of these, which is gonna remain actually there. So at the end of the day, we are now asking ourselves that, what is it that we're going to have from this part? Okay, let's just put it on top here and see, let's see what you're going to have, guys. So it means this will be 1 minus cos 2 theta, everything over sine 2 theta. All right, so there are so many ways that you could have done this, and I will know from our identities cos 2 theta, guys, has got 3 identities that match this cos. Remember, cos 2 theta can be written as cos squared theta minus sine squared theta. The same cos 2 theta, this one can be written as 2 cos squared theta minus 1. The same cos 2 theta can be written as 1 minus 2 sine squared theta. So which one is the best identity for us to use? Since my answer is somehow related to sine, something like that, sine. So you can change this to sine. Okay, so we can use this one of sine 1 minus 2 sine squared theta in place of this cos 2 theta here. So it's gonna be 1 minus, we open bracket because this is actually an expression that we are supposed to substitute here, which is 1 minus 2 sine squared theta, everything over sine 2 theta. We know again our identity for sine 2 theta, that here sine 2 theta is actually equivalent to 2 sine theta cos theta. So that means we can actually play around with this identity, and it's going to be that here, which is a 2 sine theta cos theta. All right. Seems like we're almost there. We're going to expand brackets. Yeah, let's just expand our brackets and see what you're going to have here. 1 times, it's a minus and minus here, which is a minus and a plus. It's going to be a minus here and a minus, and this will give us a plus. So it will be plus 2 sine squared theta. This is everything over 2 sine theta cos theta. All right. We are almost there. We're gonna have this here. As we can see, we've got like terms that can actually cancel each other here, which is 1 and minus 1, then versus 0 there. So we're gonna be left with what? With 2 sine squared theta over 2 sine theta. So at the end of the day, we're gonna see that we are going to have something like 2 sine squared theta, everything over 2 sine theta cos theta here. Now let's play our magics. In this case, we can cancel whatever that we can. The 2 and the 2 can cancel the sine here into this sine. That means we're gonna remain with sine theta on top there. And if you are to simplify this further, it's going to give us something like sine theta over cos theta, which we know that this is actually equivalent to tan theta and is equivalent to our right-hand side, because all we needed is to prove that this is going to give us tan theta at the end. So that is what we had, guys. Seems like, so it's actually like, it's a matter of play around. This identity is just a matter of play around part where you can use any suitable. So actually what you're gonna do is to work with different workings and calculations. So not to worry about this. We're gonna come back again, work with them. Different methods and ideas in order for us to simplify this. So I shall do that. Okay, anyways, let's see the other part, the one that we had, which is on number 3. So like I said, we shall just work on 1 or 2 of the questions. The rest, we shall see them in our other class. Okay, on number 3, we are given that in this case, y is equivalent to ln cos. Show that dy dx is going to be something of this nature, and it's 3 marks for that. Okay. So that seems like we've got a lot of working again to look at or to work on in this case. So that's going to be something else here. All right, so I could have just cleared this out, but no problem. Let's see what we're going to have. So this will be our number 3. In this case, I'm just going to rewrite this. We are given that y is equivalent to ln, that was cos squared. I'm actually having the hard copy, so it's going to be cos squared, something like this. Cos x squared plus 1, like this. All right, that is our value of y, or the expression or the equation for what? The equation for y. So how can we have this y, or how can we solve for y in this case, or how can we find dy dx? Because we're asked to show, let me just write down the part that we're asked to show. We want to show that dy dx must be equal to negative 2x. In this case, it was a negative 2x tan x squared plus 1. All right, so this is actually what we are being asked to prove or to have at the end of the question. So what are you going to do, guys? If you have to cross-check here, this is actually derivative. And how do we simplify this type of a derivative? We can actually use our chain rule, that is function of a function. Okay, so using chain rule or function of a function, we can actually see that here we can introduce a letter that in place of this whole part, this one. So it will be a function of function, and inside that function of it will be a function of function again. So what am I trying to say? Okay, I'm trying to say we can have this whole part as our u. Okay, so you can just let our u be equal to cos x squared plus 1. Okay, that's our u here. And by having this as our u, remember when you are working with function of function, the formula is going to be like this. Let us just write our formula down so that it can help us. This is the formula for function of a function, which actually tests that dy dx. If you want to calculate dy dx, you are going to use this formula, which is dy du. That's going to be dy du times du dx. All right, so that's our formula. So here we have got dy dx. This is dy du dx. Okay. If I am to consider what we have got here, we said let this be u. So we can actually write, because here we shall have our du with respect to x here, but we need to rewrite now in this y in terms of u. So which means in place of what? In place of this whole part, of course, we're gonna substitute with u. So which means our answer, or this y, is going to be ln u. Okay, so y is equal to ln u, or u is equal to that. So we've got 2 things here. From this part here, we're gonna determine du dx. Remember, this is what you need on your du, sorry, this is dy du. Remember what you need here on your formula here. Let's get our formula here. We need du dx here, dy du, which is dy du. Okay, so these are the 2 things that you're going to need from this part. So that's what you're going to have at the end. So what are you going to do in this case? Let's just differentiate cos squared x plus 1. This is going to be a function of function again, this one. But in this case, guys, just find the derivative of this. It's an easier way. Just find the derivative of what? Of the bracket, which is this x squared plus 1. So you can actually find the bracket of this, and it's going to give us 2x, but take note we are dealing with cos, where we know that the derivative of cos gives us a negative sign. Okay, so it's going to be the derivative of this, which is actually 2x, but multiplied by the negative of the trig for cos, the one that we are dealing with from cos. If you want the derivative, it will be negative sign, and this will be sine x squared plus 1. Remember your derivative, guys. So this will be minus 2x sine x squared plus 1. Okay, then we move on here to dy du. We are dealing with ln, and we know that the derivative of ln is going to give us 1 over u. So this will be 1 over u. If it was x, it will be 1 over x, something like that, but this is just u. All right, now let's take back this into our information and calculate our dy dx here. All right, so we are saying that dy dx is going to be dy du. In this case, if we are to get back here dy du, your dy du gave you this value, which is 1 over u. So we obtained 1 over u here. That's going to be 1 over u times du dx. So I want you to see that on your du dx, this is what you obtained. So what we are going to write this part as it is, which is negative 2x sine, this will be x squared plus 1. All right. So using this information that we have got here, take note, this is dy dx, but our answer is having a u on this part here. So you have to replace this u. So you have to go back here where we introduce this u to be x squared, this whole part here. Remember, we said this u is going to be cos x squared and so forth and so forth. So it's just a matter of taking that information back into practice. Okay, so let's take this part as our u down here. So we're gonna have our dy dx will be written now this way as 1 over u. We said our u here. Okay, let me just put so that you can be clear. Cos squared x plus 1. So it's going to be cos like this, cos x squared actually is cos x squared. Okay, it's fine. We're going to rewrite this. It's going to be cos x squared plus 1 like that. Okay, multiply by negative 2x. Already this is having x, so there's nothing that is going to change here. You just write this as it is, just over 1 so that it can become a fraction. So as we can see here, we can actually combine our fractions. How are we going to combine this? By just combining the numerator and the denominator. We shall have something of this nature, which is negative 2x sine x squared plus 1, everything over cos x squared plus 1. And these two here, they've got a great relationship. Remember the relationship of sine and tan, that we know that sine x over cos x gives us tan x. So that means here we've got x squared plus 1, x squared plus 1. So this is going to be tan x squared plus 1, just like what we have there. You have to write our answer with that part. Okay, so that means here this is going to be dy dx is going to be written as negative 2x. This part is just going to remain as it is. But I'm saying this part, the whole of this part that we are having here shall be replaced with tan. But now it is going to be tan x squared plus 1, just like the way we are given here tan x, but this one will be tan x squared plus 1. Okay, so as you can see, guys, that's what we needed to show this part as just a few calculations that you needed, an introduction of u, then to apply your formula. Remember, if you're dealing with chain rule or function of a function, that's the formula that you need. And with this information, that's actually what we needed in this case. So let's just cross-check another part that we had in this case. All right, let's just cross-check another part that we had. All right, so we have got this part here. Okay, on number 4 now, this is actually number 4, where we are given, this is just variation, guys. As you can see, this is variation. Given that M varies, M is inversely proportional. Inverse, that means we've got something like this, M, let's just indicate it here. We've got something of this nature. M varies inversely, so it's gonna be like this. M with the variation sign. So it varies inversely, that is proportional to the cube root of this. So it's going to be 1 over the cube root like this. So this is the cube root of n minus 1. Okay, that is what it means actually from your variation techniques. So it can be an advantage here if we are to apply this information, or if we are to know this information very well. I don't know if this can be clear if I'm to take it down here, or let us just rewrite it. It can be much. All right, so let's just take this part, guys. I want us to have this part here. All right. So let's just take this. I want us to have this part. All right. So from this information, let's put it down. It's gonna help us. I can just even put it here, guys, so that it doesn't waste much of our time. So we say that M varies. This is what we said. M varies inversely, which is inversely proportional to the cube root of n minus 1. So remember from your variation that you have to introduce what? You have to introduce the constant of variation. That's going to be M is equal to K over the cube root of n minus 1. Okay, so now let's take our information here. All right, we have got the values, so we need to find the value of K first, because that's what you're given. Formula connecting this part here, when you're given the formula connecting, take note, we are referring to a formula which connects M and N, which means we have to find the value of K, which is the constant. So we have to find that value using this information, because we are given that N is equal to 9 when M is what? When M is 5. So we're just going to take this information down, our N, which is 9, and our M, which is 5. All right, so let's just put this information down here. Remember, we said our N and M. So our M in this case is 5. So you're going to substitute in place of M, that's 5. In place of K, we're going to substitute the value of N, which is in this case, that's 9. So it's going to be 9 minus 1. So that's what you're going to have in this case. Moving on, we can actually calculate the value of what? The value of K here, this part from your calculator, it is going to give you something like 2. So you've got 5, which is equal to K over 2. So cross multiply, we can have the value of what? We can have the value of K. That's K is equivalent to 10. So if our K is 10, therefore, the relationship between M is going to be M is equal to, we have to return back to this stage here. All right, where we said our K is 10 now, and the rest is just going to repeat as it is. So it's going to be the cube root of n minus 1. Okay, so that's what you're going to have. Just like that from your variation, guys. I think if you can relate from your O-level mathematics stuff, you can actually have a lot there. So, but that's actually what we had in this case. All right, so we've got a relationship between M and what? M and N. And the other question now was now to calculate the value of the exact value. Take note, this is the exact value that we are calculating here. We want the exact value of N, given that M at that moment is what? Is 25. So we need the exact value of N, given that M is 25. Okay, so we've got the value of M here, which is 25. So this is like item 2 part that we are the one that we are having in this case. So it's just like a matter of continuation, the one that we are given here. All right, so let me just remove this part here so that at least it can actually help us to attempt this question properly. Let's just remove this part here. I don't know if it is going to be much clear. All right, so let's just remove this part here. Okay, it's fine. So we said now this is actually B, the B part. This is our B here. Okay, guys, I'm okay, it's fine. Let me put back on my marker. All right, so this is my item B here. All right, I have the value of M, which is 25. So I'm just going to make it a continuation from this part here, since I've got the value of M here, which is now taken to be what? To be 25. So I'm going to start from there to say that 25 is equivalent to 10 over the cube root. So it's going to be the cube root of n minus 1. All right, something like that. So remember, I want to calculate the value of n. So it's now back to normal equations. It's now you and those equations. You must be able to know your equations very well, guys. There is nothing actually that you can do without the idea of what of these equations. You must be very good at your equations, at least that way it can help us a lot. Okay, so anyways, what are you going to do? How are you going to apply our equations? We can just cross multiply to transpose. Here is going to be multiply this side, so it's going to be 25 into the cube root of n minus 1. Okay, everything which is equivalent to what? To 10. So we can divide by 25 here. We can divide by 25 here. That means this can cancel. And we will be left with the cube root of n. Let me just put it aside here. Yeah, let me just put it aside. So we are going to be left with this part, which is the cube root of n minus 1, which is equivalent to 10 over 5 over 25. Actually, you can reduce this, is fine. You can reduce these guys. Okay, that's what you're gonna have here. To remove the square, just this cube raised to the exponent of 3 to the exponent of 3, that will be n minus 1. This will actually neutralize each other, and that will be 10 over 25 to the exponent of 3. So to find n, we simply have to take this -1 to this side of the equation, so that it will be a plus. So it will be 1 plus 10 over 25, in this case, to the exponent of what? To the exponent of 3. So adding or simplifying these together actually is going to give us 133 over 25. Yeah, over 125. So it's going to be 133 over 125, which is our n in exact form. So that's what we needed in this case. You can just leave your answer like that, it's fine. So you see that, guys, these are the typical questions that you actually have, the basic questions. So we shall meet again from Amazon African Motives, working on other questions and revisions from past exam papers. Actually, we shall have a continuation from where we left from this past exam paper, so that we'll be able to understand how do we answer these questions specifically for our exams which are ahead of time. So you have to prepare for these exams that are ahead of time. But for the meantime, that's what we hear from Amazon African Motives till we meet again.